Good morning, students. Today, temperature and entropy diagram. Temperature, entropy. Temperature, entropy diagram. దీన్ని TS diagram అంటాం. Temperature, entropy diagram, TS diagram. Okay. Very important concept. Very important concept. TS diagram. T means temperature. S means entropy. Okay. Let us consider temperature along the y-axis and entropy along the x-axis is called as TS diagram. Okay, let us temperature along y-axis and entropy along x-axis is known as temperature entropy diagram. Temperature is known as temperature entropy. Okay, next one. Consider the Carnot heat engine is cyclic process. Carnot reversible cyclic process. The following operations is the 4 steps. The Carnot heat engine, the working substance of the following operations, the following steps, 4 steps. First of all, first one, isothermal expansion. Second one, adiabatic expansion. Third one is the isothermal compression. Fourth one, adiabatic compression. Okay, the following 2 diagrams, TS diagram and a pressure volume diagram. This is the pressure, this is the volume, this is the rectangle, this is the temperature, This is the entropy S1, S2. T1, T2. Next, A, B, C, D, E, F. EF. Okay, this is the isothermal. This is the adiabatic. This is the isothermal. This is the adiabatic. Next, pressure volume diagram. Pressure volume diagram. Isothermal, expansion, adiabatic, expansion, isothermal, compression, adiabatic, compression, A, B, C, D, compression. The two diagram is based on the TS diagram. Okay, pressure, volume and temperature and entropy diagram. First of all, let us consider the Carnot cycle, the working substance, the following four parts: isothermal, expansion, adiabatic, expansion, isothermal, compression, adiabatic, compression. The four methods. First one, diagram. Diagram is explained AB, BC, CD, DA. AB, BC, CD, DA. Isothermal, AB, DF, S1. Next one, same procedure, the system of pressure volume diagram and temperature and entropy diagram. Okay, first of all, the Carnot cyclic process, the four operations. First one, isothermal expansion, adiabatic expansion, isothermal compression, adiabatic compression. First diagram. Isothermal expansion is the at the temperature T1, at a temperature T1 from source. Isothermal expansion at a temperature T1 from source. Next, adiabatic expansion fall on fall on temperature T1 to T2. Next, isothermal compression. అంటే ఇది మ్యాటర్ ఏంటంటే నాన్న isothermal expansion at a temperature T1 from source and adiabatic expansion fall on a temperature T1 and T2. Next, isothermal compression at a temperature rejected at a temperature another rejected at temperature T2 from sink. Next one third చెప్పులోకి ఏంటంటే నాన్న థర్డ్ చెప్పులోకి rises of temperatures T2 to T1. Okay, this is the isothermal expansion, adiabatic expansion. Isothermal is represented by along the straight line AB, and the adiabatic expansion is represented by the along the BC, and isothermal compression is represented by CD, and adiabatic compression is represented by the DA. Isothermal expansion at a temperature T1 from source, and adiabatic expansion, the adiabatic expansion fall on a temperature T1 and T2, and isothermal compression, the isothermal compression at a temperature and a rejected temperature T2 from sink. Adiabatic compression arise from temperature T2 to T1. Okay, this is the first diagram. Next diagram, let us consider the following construction of TS diagram. This is the rectangle box ABCD. The rectangle box ABCD. Another rectangle box DEF. చూడండి ఇక్కడ temperature T1 T2 S1 S2. Along the x-axis entropy, along the y-axis temperature. Okay, the diagram బేస్ చేసుకుంటే 2 diagrams ఉన్నాయి. ప్రెజర్ వాల్యూమ్ డయాగ్రామ్, టెంపరేచర్ అండ్ ఎంట్రోపీ డయాగ్రామ్. అలాగే let us consider Carnot cyclic process, the 4 operations: isothermal expansion, adiabatic expansion, isothermal compression, adiabatic compression. Okay andi, this is the diagram. Next one, TS diagram explanation of TS diagram. First isothermal expansion. The isothermal expansion, the amount of heat Q1 at a temperature T1. S1 equal to temperature T1 into S2 minus S1. S1 is the entropy S1, isothermal expansion. The system is change. Entropy S1 equal to temperature into S2 minus S1. Next one diagram. This explanation of TS diagram. చూడండి ఒకసారి AB. This is the ABCD is a rectangle box. ABCD is a rectangle box. AB is the isothermal expansion. along a straight line AB from diagram during isothermal expansion AB at a constant temperature T1, at a constant temperature T1 T2 T1 T2. Okay, first point, from TS diagram during isothermal expansion at a represented by along a straight line AB at a constant temperature T1. Next, the entropy of working substance is increasing S1 to S2, S1 to S2, S1 no S2. Okay. First, the first is explain isothermal expansion along a straight line AB at a constant temperature T1. The entropy of working substance increase S2, S1 and S2. Therefore, S1 equal to the temperature T1 into S1 minus S2. Okay, S1 equal to the Q1. Sorry, Namji. Q1 equal to T1. Okay, they explain diagram only first diagram. రఫ్ చేసి సెకండ్ డయాగ్రామ్ ఎక్స్ప్లెయిన్ చేస్తానండి. ఒకసారి డయాగ్రామ్ చూడండి. ఈ డయాగ్రామ్ మనకి ఏం కనిపిస్తుందంటే ఫస్ట్ వన్ ఐసోథర్మల్ ప్రాసెస్, ఐసోథర్మల్ expansion along a straight line AB. Okay na? Now the entropy of working substance increasing S1 to S2. Okay, the amount of heat Q1 equal to temperature T1 into S2 minus S1. Q1 equal to temperature AF into S2 minus 1 అంటే AB. Q1 equal to area of AB EF. Next one, BC adiabatic expansion along a straight line BC, no change, it does not change in entropy, no change of entropy. Next one, third, isothermal compression along is represented by CD. Okay. Next, third, isothermal expansion along a straight line CD, the entropy of working substance, S2 to S1, S2 to S1. Okay, therefore the amount of heat Q2, equal T2 into S2 minus S1. Okay, AF S1 minus S2. Next one, మన డయాగ్రామ్ లో మనం బేస్ చేసుకుంటేనా దట్ ఈక్వల్ టు Q2. చూడండి, T2 అంటే డిఎఫ్, ఫిగర్ కనిపిస్తుందండి, డిఎఫ్ T2 డిఎఫ్. S2 అంటే డిసి. ఓకే అండి, ఇప్పుడు టాపిక్ ఏమవుతుంది, ఏరియా ఆఫ్ DCEF. Fourth one, adiabatic compression along a straight line DA. ఇది 4th అండి, ఇది 3 అండి, ఇది 2 అండి, ఇది 1. ఇక్కడ కూడా do not change of entropy. ఓకే, డయాగ్రామ్ లో మనం అబ్జర్వ్ చేసేది ఏంటంటే ఏ నుంచి బికి ఐసోథర్మల్, ఓకే, ఏ నుంచి ఏఎఫ్ కి అంటే టెంపరేచర్ T1, టెంపరేచర్ T2 డి నుంచి ఎఫ్ D2. నెక్స్ట్ ఐసోథర్మల్ ప్రాసెస్ అంటే అరైజింగ్ టెంపరేచర్ కాబట్టి మనం ఏం చేస్తున్నాం, ద చేంజ్ ఇన్ ఎంట్రోపీ ఇంక్రీజ్ S2 మైనస్ S1 అంటున్నాం. నెక్స్ట్ దీనికి వచ్చేప్పటిలోకి డిక్రీజ్ S2 మైనస్ S1. ఫస్ట్ వన్ ఐసోథర్మల్ ఎక్స్పాన్షన్ కి ద ఎంట్రోపీ వర్కింగ్ సబ్స్టెన్స్ ఇంక్రీజింగ్ ద ఎంట్రోపీ S1 టు S2. ఐసోథర్మల్ కంపారిజన్ వస్తే ద అమౌంట్ ఆఫ్ హీట్ Q2, ఓకే, ద ఎంట్రోపీ ఆఫ్ వర్కింగ్ సబ్స్టెన్స్ డిక్రీజ్ S2 టు S1. ఇక్కడ టోటల్ గా ద అవైలబుల్ ఎనర్జీ is given by Q1 minus Q2. Q1 అంటే వచ్చిందన్న మనకి ఏరియా ABEF మైనస్ Q2 ఏరియా DCEF that equal to area of ABCD. Available. Okay, from TS diagram, very important diagram లో 4 main parts: isothermal expansion, adiabatic expansion, isothermal comparison, adiabatic comparison. AB is the isothermal, BC is the adiabatic comparison, and CD and dA is the isothermal and adiabatic comparison. Next, AF is a temperature T1, DF temperature T2. Isothermal process S2 and increasing entropy S2 minus S1 and decrease entropy S2 minus S1. Okay, this is the first isothermal expansion. Second, no change of entropy. Adiabatic expansion, adiabatic comparison. No change of entropy, only change of entropy. Isothermal expansion, isothermal comparison. Okay అండి. నెక్స్ట్ నోట్ చేసుకుని ఒకసారి చూడండి. Next, the change in entropy of efficiency is given by efficiency is given by eta equal to q1 minus q2 by q1, that equal to q1 అంటే వచ్చినా area of AB CD by area of AF into AB, that equal to area CD by area AF, area AF. Total ga this is the TS diagram. Temperature ఎట్లా చూస్తామంటే 1 minus T2 by T1 or లేదా T1 minus T2 by T1 eta equal to 1 minus T2 by T1. This is the entropy TS diagram.